Just to remind everybody that we are recording this session, if that's okay with everyone. Any objections? No? So I'll just, first of all, I'm going to say a few words about what we've been up to, and then we're going to have a Q&A session with Brett Hawes from John Holland about the work we did with AlertSafe. And then Mark Wallace is going to say a few words about what we've been doing, and then Julian's going to give us a demonstration of some of the work we've been doing on our new user interface for the dynamic transport optimization product. And then after that, we can have a Q&A general discussion. So just to introduce everybody, David Haynes, we'd like to say a couple of words.
Well, thanks, Alan. Yeah, myself and our team have participated today because we're obviously very keen to look at the transport optimization and the work that we initiated with yourself around inventory management. So for our fuels business, so we can see the significant value that the Opturion product will deliver to our business. We've now just got to crack on with getting a project up and running. So, but yeah, thank you for the opportunity to participate today.
Oh, well, thank you, Dave. That's a good development.
Absolutely.
And nice to see you, Wayne. Wayne, that's well. Oh, you're there. Yeah.
Hey, how is everyone?
Very good. Thanks.
I hadn't unmuted myself. Yeah.
If you got your camera as well, Wayne, that'd be good.
Yeah. Okay. You scare everyone. No, it won't let me do it. All it wants to do is rename me. Every time I go to press the camera button, I can't get to it.
Don't worry, relax.
Yeah, can't get to it. Each time I try to allow the camera, the rename button comes up over it, and I can't get to it. So yeah.
Must be your cybersecurity
protection. Yeah. Can't take my face and run away with it. Looking forward to whatever you've got planned for today. I must admit I hadn't read the full brief, but I look forward to it.
Okay, so Anu.
Hi, Alan. Nice to see you after a while.
Yeah, it's been a while since we've talked.
Good afternoon. Yes, good afternoon to all. Just for the benefit of all, I've been doing some work in the steel industry. As you can understand, steel manufacturing is a very complex process, and we are trying to identify which bits of the process we can start with. And so that's the idea today. I thought I'd learn more about the bits and pieces so that at least we can get started in some aspect of the operation as we move on. So look forward to this discussion.
Good.
Thank you, Alan.
And Mark Howard, you got a camera, or it's yours not working either? Oh, it's on mute. Okay, and I see, Paula, you've joined at last, so you said you may have some difficulty. Do you want to say a few words?
Oh, no, look, I've been dealing with a runaway dog, so I've managed to get her back.
That's right. And Neil from Level Crossings.
Yeah, having a bit of bandwidth fun here, but no, very interested in looking at the capability of the product for fatigue risk management and the rostering process. So that's our interest here.
Nice to see you, Andreas.
Hey, Alan, just thought I'd come and look in. I'm sort of two-timing between two different conferences at the moment, so I might not be able to stay the full hour, but just hanging out for a bit.
That's right. And Mark Howard tells me that his audio's having a few issues. So look, I'll kick off and hope Brett's going to join us at about 9:10. So this has been a very interesting couple of years for us, trying to do everything remotely. There's been good and some interesting good and interesting not so good things, but we've been concentrating mainly on developing some new technology, and obviously Ian's been You know, just busy engaging with. Oh, sorry, I forgot to mention you, Darren.
Not a problem.
The screen's been moving around a bit.
That's okay. I just got a general interest in optimization, so looking forward to the discussion today.
Yeah, and Frank, are you with Reliable? Frank Cope, you just come on the screen.
Yeah, how are you, Alan? Yeah, we're with Reliable Petroleum. Yep.
Yeah, we've not met. Yeah. Oh, thanks for coming. Anyway, so the main things we've been doing is taking the alert safe software to, if you like, a higher level. As you'll see, we've got some fatigue models in there already that are designed to deal with a night shift or an afternoon shift or a day shift, and that's been quite successful and quite useful. But a number of customers have come to us and said, look, we don't really do that. We have long periods of work where it's intermittent, or we have issues with callouts. So we found this with people like the pilots in the ports, and also St. John's Ambulance, who do all the emergency ambulances for Northern Territory. In some of the remote areas there, the crews basically work 48 hours straight. But obviously they're not at work for 48 hours. They have spells where they need to do stuff and spells where they don't do anything. So that was a bit of a challenge. So we've actually implemented a new model from Monash University that is rather interesting, and we can have a look at that later on, where the model predicts not only the fatigue level, but also predicts when you're likely to sleep. And it's been giving us some quite interesting results. So, for example, if you are working a night shift on call and you get a call out, you come back, it predicts that you're going to go to sleep. And obviously during the day, it's not so likely you're going to sleep. So we found that quite useful. And we found use cases for that in things like maintenance activities where people do a day shift and then they might be called out in a night shift for an emergency. So that's one of the developments we've been working on. The other thing that has been happening is that we've had a number of customers ask us if we can build something a little bit more traditional when it comes to the interface to our dynamic transport optimizer. So it's probably most of you know there is an upload from Excel. Some people like that, other people aren't so keen on that. So Julian and his team have been redesigning this as a more traditional interface where you literally interact with the system and the optimization results come back without having to upload or download. And I'm sure we'll have time at the end for Julian to give a demonstration of that. Ian's been doing a lot of work in the petroleum sector, and we've been doing developments for people like John L. Pierce with load planning. And we've found that quite a lot of people in the petroleum sector are still using Excel for everything. So we're quite hopeful that we can help them in a more integrated system where it's a more seamless integrated system rather than putting everything on Excel. And one of the customers said to us, oh, we're way ahead of that. We're using Google Docs. But I don't quite think that's what we meant by integration. It may well keep it in the cloud, but it's not really any different. And finally, we're working with the Race for 2030. That's an organization. The race is reliable, affordable, and clean energy. And we have a project running in that where we're looking to use our optimization technology to help people make more informed decisions by looking at the options for decarbonisation, green power. It's a bit of a diversion from transport optimization, but it's a very interesting decision support problem. So in terms of new clients, we've been working with Hitachi and Rio Tinto on train scheduling and optimization, Lang O'Rourke on optimization of rosters for level crossing removals, ongoing work with Ambulance Victoria. You've probably read in the news that Ambulance Victoria are doing a lot of work around reducing fatigue and improving work patterns. And we've been, if you like, the back end of the analysis, where we've been looking at how many ambulances are required, calculating the optimal shift patterns, looking at issues around location of ambulances, their workload, and completely redesigning the rosters. And this is no mean feat, because they've been looking to try and do something like this for a lot longer than Opturion's been in existence. In fact, I was talking to someone the other day, and I said, I think it's about 6 years. And he said, no, it's more like about 15. So, and this is quite an important development, because they had been doing some quite punishing shifts, which out of choice, because they like to do a long shifts and then have lots of days off. But there is a balance where sometimes it's best to sort of moderate between that. So we've been helping them solve that problem. So before Brett comes on, were there any questions or interest in that? Don't be shy. I've agreed with him that I'd get a bit of a précis about the project, because he was the health and safety manager who came in almost at the end of the project, because they changed health and safety managers during the project. So he said, oh, I don't know all the details. So I'll give you a précis of the project, and then hopefully he'll come in within a few minutes. So we were asked by John Holland, as part of the Northwest Programme Alliance, to look at generally the fatigue on the project that was to replace level crossings at Bell Street in Preston and Coburg. And this was a particularly unusual project, because normally these occupations, they call them, which basically means that the railway is closed, were going on for about 30 to 40 days typically. And for those short periods of time, the engineers were working something like 12-hour days or 12-hour nights, followed by 2 days off. Oh, there's Brett now, so good. Oh, there was, oh, he's come, hopefully he's connecting. But the issue was that and the occupation at Bell Street, Coburg, was due to go something like 97 days. And the concern was that that sort of, look, oh, hi Brett.
G'day, how are you, Alan? Apologies.
Yeah, I'm just giving my rambling introduction to the discussion, so you can hear it now anyway. Good to see you.
Thanks. I think everything that's gone wrong this morning could, including
right. Well, this is the first one, so don't expect everything to go right.
No worries.
So I was just saying, Brett, that the concern with John Holland was that a 97-day occupation would be too long to work such an intensive schedule, and there were concerns that there might be burnout or you know, other issues around such a long time. So we were given the job of looking at a number of things all around this issue of how can we man up the project in a more workforce friendly way, shall I say, to prevent burnout, because burnout really is not a good idea, because the concern was that there's a shortage of engineers anyway, and if they chose not to come back to the next project, then obviously that's a major issue. So the first thing we did was to look at the project plan and work out how many engineers will be required. And this was a slight departure from normal, because we looked at things like, well, okay, do the engineers need to be on site? Do they need to be at location, or could we just, you know, there were 2 locations, and the question was, could we have one engineer covering 2 locations? Do we have to have the engineer at location? Do we have to have the engineer on site? Could we on call? And so on. So instead of putting all the engineers on back-to-back 24-hour shifts, the question first of all was what's actually required as a manpower level. So that's a sort of resource optimization question. Then the next point was, once we worked all out, is to say, well, what shift patterns could we potentially introduce? And so the starting point was 12 days on, 2 days off. And eventually we landed on more of a 6-day on, 2-day off pattern. And the good part of that is that fits together like Lego bricks. So it means that if you need one engineer at location, you only need 4 engineers to cover that, which is a big advantage, because obviously if you have one of these long rolling patterns, you can't really isolate people. So that was one point. But then the second question was, even 6 12-hour nights was deemed to be maybe too fatiguing. So we made a big break with precedent and actually proposed a 3-shift system, where there was a morning, an afternoon, and a night shift. And even then, we broke away again from precedent by suggesting that maybe we should have a shorter night shift and a longer day shift. There were some concerns that, well, that means more people, right? So can we afford it? But at the end of the day, I think because we optimized the number of people on call and on site, it was still productive and cost effective. So the final thing we did once we designed all this was we gave them John Holland the Alert Safe tool to manage the execution of the shifts with a number of different other tools around fatigue management. So that's my introduction. So Brett, I was going to sort of come back and get your perspective on how things worked and what you think John Holland learned from that.
Sure, thanks, Alan. Good afternoon, everyone. Apologies again for being late. I guess just to preface my comments, I picked it up sort of right at the commencement of the occupation, as in I joined the program. So some of the heavy lifting and the research work had been done by those before me. And then, yeah, as you've sort of discussed and highlighted, going into a long occupation, occupations in the rail industry can be typically very taxing. And it's almost like, how many occupations have you got in you is a common question that people ask. And traditionally, they can have an impact on your lifestyle. And so, people can only do them for a certain amount of time, and then they sort of move out into other areas of construction. So for us taking on that 97-day occupation, it was really important that we came up with a solution that was beneficial not only to our people, but also maintain program and ensure that we got to the end with a safe outcome. So that's where we touch base with people like yourself and Paula Mitchell, just working through different scenarios to come up with a solution. And we came up with a mixed bag of solutions. And as you've discussed, one of them was the 2-2-2-2, which was the 2-day, 2-afternoon, 2-evening solution, which was implemented, and we had some good outcomes with that. Talking to a couple of people who had previously done, say, 45-day occupations, and at the end of those 45 days were completely exhausted, burnout mentally and physically. They were functioning adequately at a 45-day mark of the occupation on the roster system that was implemented. So they were really positive working with that new system. So I guess that was probably one of the key things. And I think, probably some things that we would look at is just certainly look to implement a similar sort of process again. At the moment, a lot of our occupations are short term, but looking to go longer, it'd be definitely a system that we'd look to reintroduce to how we manage it, and then probably have some live data feeding in, some dashboards along the way, just to give us that visibility throughout the process.
Okay, thanks. So how would you comment on the change management? Because, often with projects that we do, the change management is a very, getting people to change. How do you think that went?
It was good. As you mentioned, change managers is a huge thing. And also, our numbers of resources, just project staff required to run this occupation. And you're talking about engineers who actually cover all disciplines. So your environmental, safety, quality, supervision, design, everyone gets involved in that rostering system. So we had some pretty high numbers of staff. One of the challenges we probably faced was getting all those people on board, ready for the occupation, and being able to go through that change management piece with them. Typically, we don't have the numbers on the project until maybe a week or so before we're ready to go live with the occupation. So for us, it'd be picking up all those people, who they are, and getting in front of them a lot earlier, just to go through that piece and make sure, you know, they're proficient with how we want to run the rostering system, what tools we've got available, and what some of the outcomes are that we're looking at the end of it.
Yeah. So just for the benefit of the audience, I guess, what would you have used otherwise if you'd have done things the same way as you would have done?
So there's that default platform that people use called Excel spreadsheets. Fantastic, you know, document back in its day, but that really is it. You know, that with a couple of formulas in there to trigger off, you know, exceedances and things like that, and then a team of people to enter data and manage that throughout the whole thing. Yeah.
So how would you say I mean, and as far as I can see, this is an unusual situation, because you might consider fatigue for, if you like, the manual workers, for the sake of argument.
Yep.
But I think it's very unusual with more professional people. The idea is, you know, they can just work until they drop. How do you see this sort of evolving in the engineering profession?
I think it's opened the door. I mean, COVID's probably opened the door to a lot of things as well. So, you know, there's benefits certainly from that, with people working from home, flexibility that's come into play. That, you know, 18 months ago, 20 months ago, flexibility was a word that everyone probably dreamt of. And if you hadn't said in 2 years, 60-70% of your professional workforce will be doing part of their time at home, you'd say, well, that's ridiculous, and how are we going to manage that? But we have been able to manage it. So with this rostering system as well, I think, you know, working alongside COVID and some of the changes, it's certainly, we've made inroads into how we do things differently. I think, you know, looking at a wider piece too, we're in a pretty competitive market at the moment as far as the amount of construction work that's on. So we've got to look at what is it that we're going to offer our people, which is going to make our place a great place to work. You know, and if it's telling them they're going to work 14 or 15-hour days, 7 days a week or 6 days, we're probably going to take ourselves out of the market there. So that's been another factor which has assisted in, you know, trying to make work a good place to be and stay in. And I think, you know, working with some industry groups as well, we're going to see a lot of progression into, you know, how do we do this differently to make it sustainable for our people. Yeah, that's a good point. So the last thing I was going to ask you about is the award that you applied for. I know you weren't successful, but I think that's interesting to. Yeah, definitely. So I guess, you know, and credit to Phil Walton too for the work that he did up front, looking at how do we do things differently and taking on the challenge. It's one of those things, I guess, sometimes that people want to know about, but sometimes they don't want to know about it. So, you know, Phil had some great concepts, and I guess it's working towards making that change in the industry. And the trial, the work with the subject matter experts in the industry was really a piece about trying to make that step change and put something on the table. So we've got some baselines to go back to and sort of look at. And that was where that award with the Australian Rail Authority, I guess, was pushed through to look at, you know, what we're doing differently to make some changes. And we're a part of the level crossing removal program. And one of the great things about that program is that even though we have 5 alliances not competing against each other, but traditionally, you know, your opposition is your opposition. Within the level crossing program, it's really about what do we do as an industry to bring each other up and learn and share from each other. So, you know, I guess we're fortunate that we're in that space where it's supported to take these steps, look at how we do things differently, and can we share things in the industry to make a significant change. Okay, look, thanks very much for those insights, Brett. I might throw it open if there's anyone in the group would like to ask a question.
Yeah, I've got a question. Brett, I know that when I've been working with, some other similar organisations, and we start talking about hours of work and particularly around those intensive periods like the occupations. And I know that from their perspective, often they'll say, well, the project has been won on a particular budget and that's been based on a 2-shift system with people working 12 hours. And so when you start talking about doing what Northwestern did and introducing a 3-shift system, that it's basically, well, that's not even possible because then we need a whole other team of people. So I guess I'm curious to, hear, Alan sort of spoke a little bit about it in the introduction, but, how was that doable for Northwestern when so many others say, no, it's not possible?
I think, and hello, Paula. I think it's one of those things where it's just not sustainable for that length of time. And certainly it's coming a lot more upfront now in the planning and the development phase to introduce the implementation of those rosters and also the additional resources and factor it into the cost. I'm sure if we looked at the true cost of running those extensive hours, they'd be so much more expensive than what we do or what we proposed and did run with at the Northwestern Program Alliance. So it's making that step change, putting it into your pricing, and then I guess you've got to be able to back that up when you sit in front of a client to say, well, why are you more expensive than someone else? And being comfortable to, I guess, sell that risk mitigation that you've put in place. It's, like I said, if we start talking about fatigue, it's something that people want to know about that they don't want to know about. And even, having a conversation earlier today with some people, there's specialist trades, resources that fly in and out from around Australia to do work in different aspects. And they'll only come here if they do a 12-hour shift. And they want to do X numbers of these shifts per week to make sure they maximise the amount of money they're going to earn. Otherwise, they don't turn up. So we're really caught in a bit of a catch-22. We've got the old mindset of this is how we do it and I'm invincible. And, if I'm at the pub tonight and I've worked a 20-hour shift, everyone probably should shout me because I'm the best worker out there. My discussion was even, do we pay these people for 12 hours and only get them to do an 8 just to get them here? Again, that's another cost burden that you need to look at. But with the shortage of resources, it's just a real challenge that we're in at the moment. And yes, you'll always see delivery people complain about people who priced projects and the fact that maybe they don't have an understanding of what we actually do on jobs. So we're getting more people from delivery into pricing to bring those lessons learned up front. And again, so that we can sit in front of a client and go, yep, you know what, we're 10% dearer, but this is what you're going to get.
I think, Brett, too, the interesting thing with the project, I think it probably was costed on a 12-12 system.
Yeah.
But I think at the beginning, the challenge was to say, well, do we actually need all these people on site 24/7? And I think that was the interesting point. And
Yeah.
COVID helped that because obviously, people can work remotely up to a point. So.
Yeah. I mean, apart from all the negatives of COVID, for us, it was absolutely fantastic for that occupation because there was no traffic on the road. So logistics of movement in and out of the project was smooth. People weren't out socialising. People weren't playing sport. They weren't doing extracurricular activities. They couldn't, go and visit people at other houses. So a lot of things worked in our favour. And again, apart from all the negatives that we've all experienced, it was probably just that perfect alignment of everything that made the project such a success.
Okay, well, look, thanks very much, Brett. Really appreciate your insight. Mark, you got a question?
Well, just one question. So for different kinds of work and different kinds of people, the pressures of shift work seems to be different. Some people say, well, in my particular job, I was talking to some guy saying, that these shifts are really tough because I have to fill in when everybody else is not around. But there's a sense that other people, there's less pressure. Is there any kind of measure of that, of which people suffer most from intensive shift work?
I don't have the answer for that one for you, Mark. I can probably relate, and you're going to go from a mental capacity to a physical capacity in some of those things. And Alan, you might be able to jump in and give some sort of response here, but I think the physical expenditure is repairable, providing there's no long-term injury. The mental one can certainly be more challenging, and people can become ingrained in thinking and working all the time, even when they're not at work. Mentally, they're still active, and it's probably a little bit more dangerous in that space.
I think one thing I'd like to add to that too, Brett, and Alan, you might follow it up. So I've got construction going on here as well. One thing that I really love about the AlertSafe software is that you actually have that capacity to put different workload and attention ratings depending on what the role is. And so for another client that Opturion and I have just done some work for, they're working the same roster, but depending on the role, they gave different workload and attention ratings, and it did come up with, like significantly different results in that roster analysis. So I think that, as I said, that capacity to be able to, assign different workload ratings depending on what the role is, I think that's, as I said, one of the things is that AlertSafe actually shows that up, the difference.
Yeah, that's correct. And the other thing that we've developed is this idea of the safety criticality of a role. So you might have a fatigue limit of, say, 40 for a person who is doing something reasonably not too safety critical, but you might reduce that if it's a person fitting some safety device to a train, or checking out a tunnel before something happens. So you can look at, so there's the work intensity, the attention span, but also the safety criticality of the roles can be changed. Okay, well, thanks very much, Brett, for your insights. Appreciate it. The next item on the agenda, Mark was going to say a few words about technology, and then we will have a demonstration of the new AlertSafe user interface. Do you want to grab the screen, Mark?
Okay. Hopefully you can see my screen.
We can.
Yeah, good. So this, after Brett's kind of introduction, there's really quite a lot of information there. This is back to a much more noddy level of description, kind of high level. So it's in the wrong order, really. But I wanted to talk a little bit about rostering, a little about the risk of incidents during shift work, and then the physiological models of fatigue. So those are the three kind of directions we've been working from.
Mark, do you want to make your screen full screen? That's it, yeah.
It's interesting with this setup, I'm getting 5 minutes to respond. So first of all, we have a set of shifts that we're trying to schedule over a time horizon. So we've got to fit these things in, but we've got to fit them in a way that satisfies a whole lot of different constraints. So for each shift, we need a coverage. We need a number of staff at different levels of expertise. So these are really important constraints to make sure that, for example, in each shift point, we've got enough people with enough skills to do each thing correctly. Then we've got to make sure that for each member of staff, we've got an admissible sequence of shifts so they don't get too fatigued. So we've got to actually manage the gaps and the rest points and the balances between the work. And that balance point is really, really important, especially for people's satisfaction with their work, as well as for enabling people to recover at the end of the week. So there's a lot of variety of constraints on a rostering problem. But when you come into actually taking into account fatigue, one example I wanted just to illustrate was work in a hospital and nurses. So you've got this complex preferences of nurses, and we talked about the constraints and the fairness, but you've also got to deal with what happens when people can't make it, people are ill, people want to swap. That affects the fatigue as well. You've got to make sure that people swap with other people and maintain the fatigue levels or the alertness levels for the people they swap with. And finally, every single rostering solution has a current process. Every organization works in a certain way. And you've got to be able to respect that process when you add actually computational support. You've got to be able to respect the expression of preferences, the notification of what people are going to do, and the process for handling changes in those shifts. So the work at Opturion comes out of a research collaboration, which was a kind of 7-year collaboration with a number of industry partners and universities. And there was modeling of the neurophysiological states of the brain as you go through a set of shifts, tested in sleep laboratories. So there's a whole lot of work on alertness within that academic collaboration. And what came out of it was innovative rostering, taking this model, these actually alertness models into account in a completely novel way. However, it's one thing to have a solution, it's quite another thing to get people to get the benefit of that solution. And I think rostering is a particularly difficult challenge in that respect, because the people, it's a very kind of political area, and the people doing the rostering have to relate very closely with the people they're rostering. But you've got not only to deal with the rostering people, but also the general regulations from the unions. What happens in terms of the IT management? So if you've got some automation going in, and that's a particularly sensitive issue in hospitals, and of course the shift workers themselves who are being rostered and what input they manage to get into it. So moving on from rostering, a quick word about incidents during shift work. I don't know if you can read this text, but the guy says, at first I thought it was just a coincidence, and then I noticed it corresponded perfectly to your shift. Different people handle shifts and rostering in different ways and handle night work in different ways. And you've got to be able to understand what's happening in terms of the causes of accidents. But if you look at some of the major industrial incidents, 3 Mile Island and the Bhopal release of chemicals, Chernobyl, the Exxon Valdez spill, and the Estonia ferry, which is what we're looking at here, they typically happen in the early morning. And if you look at tables of the relative risk values, I mean, I don't want to go into a lot of detail, but at nighttime, if you look at the right-hand column, this is where you get much more risk of fatigue and therefore accidents coming out of that. So there are a bunch of studies on relative risk rates. If you look at the successive nights of working, and you can see that in a kind of tabular form. If you look as the shift duration goes on longer, the estimated risk grows for very long shifts. And of course, when you get sequences of nights, when you've got 4 12-hour nights, then you've got a really high risk of incidents, which can have really nasty effects. So it's quite good looking at those historical results, what previous shift patterns that have been worked and what incidents occurred. You've got an evidence-based basis for saying, well, what are safe shifts and what aren't safe shifts? But the cons are that the historical data only relates to certain situations and certain shift patterns, and that may not be applicable to your own industry and your own shift pattern. So there's a complementary way of analyzing alertness, which is looking at these physiological models of fatigue. And here you look at the circadian rhythm, which is the way that we work naturally, and all animals in fact work, that they make us more awake in the day and less awake at night, which is affected by light, of course. But there's also the fatigue, just the time since you last had a sleep. And these, you can actually measure these effects and look at how the brain works and then predict what people's alertness is going to be on the basis of this past physiological data. And so there's a lot of studies of that which have been carried out at Monash and Sydney. So what we need is both a powerful rostering algorithm, a need to match evidence-based risk estimates from the past, and to be able to handle the shift patterns which are determined by the roster. And Opturion has basically combined all these 3 approaches. So that's really what I wanted to cover quickly.
Okay, thanks, Mark. Well, I think we've we've probably covered the rostering fatigue part of the meeting, and I also wanted to, for the benefit of our transport and optimization in other areas clients, to maybe have a look at what we've been doing with our dynamic transport optimizer. So Julian, do you want to fire that one up? And then we'll
I was trying to unmute my microphone. Okay.
You can actually share screen, can you?
About to try. Okay, let's see how that goes. So, can you see something there?
Yes, we can.
Yeah.
Excellent. Okay. How long have I got here, Alan?
10, maybe
10.
12 minutes.
Okay. Well, let's see how we go. Okay, so thanks. So, as Alan mentioned before, we have several. So this is what we're looking at here is our new cloud-based interface to our dynamic transport optimizer. So this is an optimizer for pickup and delivery problems. So assigning a collection of orders to vehicles and then scheduling the route or constructing the routes for those vehicles across some planning period, usually a day, anywhere can be longer if necessary. And as Alan mentioned earlier, we have several interfaces to this particular piece of software. So back when we originally started, our thinking was that the way this would work is we would integrate against clients' PMS systems and everything would be wonderful and it would just work. We still do that. One of the disadvantages is there tends to be quite a high sort of upfront integration cost in that particular case. And it often boils down to, well, how cooperative is the vendor of the TMS actually being in. So that's one option. A later option was the Excel-based interface. So this is something we use quite extensively for modeling and consultation type jobs ourselves. So in this case, the entire DTO data model is exposed in an Excel spreadsheet, and you could just manipulate things using, the usual mechanisms within Excel. So this is quite a powerful way of doing it because you can obviously leverage all of the capabilities in Excel. One of the disadvantages, among the disadvantages we've found with this is if you just say to someone, here's this Excel interface, go and use it. You have to have quite a knowledge of the DTO data model to actually use it effectively. I think one of the other issues with it is in terms of feedback you're getting, there's a step removed from it, if you like. So if you have data cleanliness issues, and in the transport domain, that's often a problem, by the time they actually show up in your solution Excel spreadsheet, you're not really in a position where you can do anything about them easily. So one of the things we've been building over about the past 6 months is a new cloud-based interface, which is really designed to allow you to explore the problem in a more visual way and explore different alternatives. So what you can see on my screen here is sort of the opening, or the start screen to this interface. And really at the moment, there's not much I can do. So I'm just going to load some data. It's there. So it'll just take a second to load. Okay. Is Zoom keeping up with me here? Yep. It's rather inconveniently put that thing in the way. So I've loaded the data now. Each of the red dots or red squares on the screen here represents a location where something is scheduled to, well, something is happening. So if I actually click on one of those red dots, it will tell me. So this is the rather unimaginatively named location 552. That's the address there. Is that visible?
Yeah. Yeah.
This was designed to primarily be used on quite a large monitor. So if you're viewing it on a small screen, it may be a little bit squashy. So there are 2 deliveries that need to be scheduled at this location. I'd like you to keep an eye on this delivery, which is scheduled up here in Mildura. That will become important later. So having loaded that, we can now sort of drill down into the different elements of the data model. So there are sort of 3 key elements in the DTO data model. There's a set of locations where pickups and deliveries are scheduled to occur or need to be scheduled to occur, and also where vehicles might start and finish. There are the orders themselves, so these are things we need to schedule, and there's the set of vehicles, so the fleet that we're actually going to use to schedule those. So using these tabs here, I can actually examine each of those 3 things. So if I start by looking at the locations. So this table shows me the set of locations in our problem here. Each location is given an identifier just to something, so essentially a handle we can use to uniquely identify it. It has an address. It potentially has a name. I think I mentioned this before, this data is somewhat contrived. The name here might be, for example, a store name or a customer name. In practice, it probably wouldn't be the same as the identifier name. We have the coordinates here. So if you want to retrieve those coordinates, we have an interface to the geocoder where you can go and geocode that address and it will tell you those coordinates. And we have some other details about what might be happening at that location. So these time windows over here represent times when this location is open and we can schedule a delivery or a pickup at that location. So for this first location, 2442, it's open between 9 and 12 in the morning and 1 and 5 in the afternoon. So from this interface, I click on this, it will open this form here and I can actually edit the details of this location. So for example, if I knew there were a restricted number of loading bays at that location, I could actually update the number of loading bays at that location. Moving on to orders, it's a similar thing. So there are a lot of details in the DTO data model associated with orders. When we display this form, you try to make an intelligent choice about what it will actually show you. So actually a lot of, for this set of data, a lot of these elements aren't particularly relevant, so they've been hidden by default. You can sit here and click on these and show them if you really want to. So the assigned cost is essentially the cost, a cost which we're going to incur for actually delivering that order. In this particular case, they're all 0, so that's why that column was hidden. So as with locations, orders have an identifier, a unique identifier associated with them. If you're in an environment where you're working with the TMS, this will usually be the identifier from within the TMS. We don't particularly care what it is, as long as it's something we can actually just something which is unique enough so that we can actually identify that order. Each order has a weight and a volume associated with it. And for those familiar with the DTO data model, we don't particularly care, what those correspond to. So I imagine they're probably kilograms and something there. So volumes, for example, might be a number of pallets, it might be a number of roll cages, it might be cubic centimeters. As long as it's consistent, the software is not overly concerned with what it is. Each order has a pickup and delivery location associated with it. And in this case, we have a service time when we deliver the order, which is essentially how long is it going to take to unload this order. So for this first order here, you can see it's going to take 47 minutes. Again, if I click on this, it'll bring up a form which allows us to edit the order. So these panes here are expandable and they represent different properties we can associate with the order. So this pane here represents information about the pickup, so where the pickup is going to occur. The pickup service time represents how long is it going to take to load that individual order. There are various restrictions we might place on the order, so there might be a pickup time window associated with this. There may be what we call a soft time window, which is we may allow the pickup to occur late, but there'll be a penalty for doing so. Similarly, we have the same sort of things for deliveries as well. There might be various kinds of costs associated with it. So there may be a monetary cost incurred for delivering that order. There may be some sort of penalty associated with that order, which is what we would call a hidden cost. And indeed, we may have some other limits associated with the order. So for some applications, you may have a situation where you have a limit on how long it takes to deliver, or an upper limit on how long it takes to deliver that job. So for example, if you're delivering food, for example, you can't take too long, otherwise your meal will get cold. Likewise, speed this up a little bit. So we have a fleet defined here. If I click on that, you can see there's various properties associated with each vehicle. So we have a set of costs associated with the vehicle. We can define overtime related costs with the vehicle. Availability time, so what's the earliest time the vehicle can start, what's the latest time it can finish, that kind of thing. Various kinds of penalties that control the shape of a vehicle's route. So do we prefer a vehicle to sort of drive out to a particular area and perform all its deliveries in one area, or do we like it to do drop-offs on its way? We can define brake schemes and define brake strategies for the vehicles. So when driver brakes must be taken, and we can impose various limits on the vehicle. So there's two in this particular pane here. So we can impose a limit on the number of loads the vehicle will carry out, and we can also require last in, first out load ordering. So for example, if you've got a rigid sided vehicle, you may only be able to unload and load from the rear of the vehicle. So in that case, it makes sense to actually structure the loads in such a way that you can, well, as it says, it's last in, first out. So going back to the dashboard page here, what I'm going to do is I'm going to start generating our transport plan, which I can do by clicking the solve button here. As I do that, the first thing I'd like you to notice is this button which has popped up here labeled warnings. So if I click on that, it's going to bring up this screen here, and this is going to tell us the system has detected that there are certain problems with some of the orders in the plan we're trying to generate for here. So this first order has a weight of 1,600, but the maximum weight capacity of any of the vehicles in our fleet is 240. So the system won't obviously be able to assign that order, given that we haven't got any one vehicle that will be able to fulfill that order. Likewise, this second order has a problem. A similar problem, this time with respect to its volume. And the third order here, we have a delivery time window on that order of between from 6 to 8 in the morning, and that doesn't actually overlap with any of the times on the location where that location is open. So again, that's not another order we'll be able to fulfill. So if I pop back to this other tab here, so it's now run. So you can see these squares have changed to green down here. So if I click on this, it's going to tell me what's happening at this location. So at location 552, vehicle 13 is making a delivery of both of those orders to that location. If I click on another location here, vehicle 6 will be delivering this order to location 3754. You'll notice Mildura up there has stayed red. And that indicates that the order up there, or at least one of the orders there is only one in this case, has been unassigned. If I go to this view drop down here, I can actually just filter out all of the assigned orders and see where the unassigned orders are. So the system is telling me I've assigned 346 out of 350 orders. In this particular case, I've actually set things up so that 4 of those orders are unassignable. So if I click on, say, this down here, I can see at location 9319, which is one of our depots. So there are 2 depots in this particular instance. There's a depot in Truganina and another one in Somerton. And there are some unassigned pickups at that Truganina depot. Just before Google Maps is just having a bit of a moment there. So you'll see also this unassigned orders tab has popped up here. So if I click on that, I can actually see in more detail why some of the orders are unassigned. In particular, you'll notice this order here, which is the Mildura order. The system is complaining that there's no vehicle that has sufficient work time to travel from its start location, complete that order, and then travel back to its end location. And it's giving us a bit of a hint that vehicle 2 would be the one we could use. It's the one that sort of has the closest amount of available time. However, the job is going to require 14 hours and 11 minutes, and its maximum working time is only 12 hours. So at that point, we're going to have to manually intervene and actually do something in order to actually get that vehicle assigned. We'll see what we can do in a second. Just before we do that, I head back to the dashboard here. And at this point, I can actually click on each of the vehicles and actually view the plan for that vehicle on the map. So if we have a look at vehicle 1 here, you can see at Truganina, he's starting at 7:34 in the morning and he's making a series of pickups. And at the end of the day, he'll finish at roughly 4:15. And if I click on, at least if the map updates fast enough, I can click on each of these locations and see what's actually happening at that location. So the 13th stop for that vehicle is at roughly 2:50, and it's the delivery for that order there. If I click on the Run Sheets tab, I can actually see that information in another form. So actually, there are more assigned vehicles here. See them all. So if I click on this green tab over here, we can actually see the run sheets that the system has generated for that particular vehicle. You can see the pickups and deliveries that have been scheduled. We can see where the system has inserted driver breaks here, according to the scheme we've defined. And over here, we can see the sort of running utilization of the vehicle as the day progresses and some other information. The other tab here just shows us various KPIs that may be of interest. So for example, the loaded distance traveled by the vehicle versus the empty distance traveled of the vehicle, the number of loads, number of deliveries, peak volume, that kind of thing. Okay, to finish off with, if we go back to our unassigned orders, so let's just have a look at this first unassigned order. So this was the one.
Julian, sorry to interrupt. If anyone's got a hard stop, I've got to just say a few things. Is that okay?
Go for it.
Look, first of all, in case you've got a hard stop, I just wanted to say thank you for coming. Particularly thank you, Brett, for doing the Q&A. We are planning to have another meetup on the 8th of March, so we'll get an invite out for that. And we've already got Andrew Swain, who's he's a commercial manager for a company called EFM Logistics, is going to talk about some work we did with them around optimizing their operation. And we'll send you a recording of the meeting. So I just needed to get that one off my chest. And if anyone would like to continue and finish the demo off with Julian, you're very welcome. We don't have a hard stop at our end. But if you do have a hard stop, again, thank you very much for coming. We really appreciate the support. And we're always happy to welcome anyone who's got something interesting to say. I think it's quite informal, and it's always interesting to hear from different people. So thank you again. So if you have to leave, otherwise please stay on. And sorry for interrupting you, Julian, but some people will probably have a hard stop at 1 o'clock.
That's okay. I'll wind it up in a minute.
No, just take your time now. You're okay.
You may regret that. Okay, so we have our unassigned order here. So really what I was going to show, and this is one of the reasons we've built this interface, is one of the problems we've encountered with clients in the past is you run the optimization and some of the orders end up being unassigned. And the question is, why didn't it assign that? And a lot of the time that sort of boils down to data cleanliness issues. I remember one particular instance we had where someone tried to pack 30,000 tons of bricks onto a truck, which isn't going to work. And the issue was simply that, in their spreadsheet, they put a couple of extra zeros in here, which is what's happened here. Well, I'm going to say it's what's happened here. So for this order here, the weight is 1,600. The maximum capacity of that vehicle is 240. So if we take that order and we just copy the order ID and go to the order sheet here, we can head up to the search bar here. If we put that in there, it'll search for the order. Let's edit that and actually fix that up. So if I double click on that, go up here, I click that. Okay, so that's now been updated. So when we rerun things, that order should be assigned. So obviously I haven't fixed those other three orders. Oh, my mouse is a little sensitive there. Let's just zoom back in. And you can see we've now assigned 347 of the 350 orders. So we've assigned that order. If we have a look at the warnings here, you can see that particular order we were having a problem with has now disappeared. So one of the things, or one of the rationales for this interface was being able to correct minor issues like that is a reasonably important thing. What we're building towards is the ability to actually define entire scenarios within this interface. To some extent, that capability already exists. So if I want to add a new location to this scenario, I can already do that. So I can define a new location. Anushree, can you give us a wave, Anushree? Wherever you are, is currently adding the capability to add new orders and new vehicles within this interface, which is a capability which will be available quite soon. So you can, if you want, entirely construct an instance within this interface. In practice, unless you're actually a very small, unless your operation is very small, that's probably not going to be reasonable. So you can, we also have the capability of pulling data in from Excel or from other data sources. So certainly if you have that, if you require that sort of capability, come and talk to us, because it's actually a reasonably straightforward thing to add that kind of thing. I guess our future plans for this, so at the moment, this sort of covers sort of the minimal aspects of the DTO data model. So we're building it out to cover further aspects such as replanning and compartments on vehicles and specifying your own brake schemes and defining compatibility relationships between orders and vehicles and that kind of thing. So that was, if you like, just a sort of very brief overview of the new interface we're building. So if you've got any questions, I'd sort of encourage you to come and have a more in-depth chat about it with us. You know, we're certainly looking for feedback on which directions we should sort of prioritize as we build this thing out. And just before I finish, so the DTO website is here. So this sort of has an overview of the entire product. So if you haven't had a look at this, I'd sort of encourage you to take a look at it and see what it's capable of. Tahara, I'm sure you can include a link to this, what you send around at the end.
I can, yes.
And I think that's it from me. Thank you very much, everyone.
Thanks, Julian. Okay, I'm conscious that we've gone over time, but again, we'd like to, if there were any topics or any things you'd like to contribute to the meeting in March, you know, we'd like to hear from you. If there's any final questions, or if you'd like to follow up with a more detailed discussion with Julian about the new product, you know, more than happy, or alert safe, or any of the other things that we're doing. So are there any final remarks or questions? Otherwise, okay, well, again, thank you for coming. Appreciate any feedback. This is the first one, so obviously going to be a little bit chaotic, but we'll get there. And by the time we've done a couple, I'm sure it'll go very smoothly. So again, thank you for coming, and look forward to catching up with you in the new year.